system, the system for load calculation of spur and helical gears. We have some technical university documents. We have license inquiry, you could ask for the system, license description, frequent asked questions, manual demo and logon. The demo is the same like full logon except possibility of input data change. And we have main panel, we have button bar, we have input data bar, we have options panel, we have status, results presentation, and result files to where you have possibility to look over the result XLS files. Let's go into the actions. We have manual, please read. We have input storage. It is a possibility to save or load data for further use, for easy taking back after a time. We can also reset input data. From time to time it is important. We have some optimization, I will show you later on. And we have solver, it is a complex solver from blank project into the final results. We have precise ISO calculation, DNV calculation, wheel measurement, and wheel reconstruction. Let's start from calculation ISO. We have done. We have on the base of input data, which were set up before the calculation, and in the range of options, it means for bending and pitting, but no scoring, because we have no marking scoring for this purpose. We have done initial geometry check, parameters check, meaning cooperation, and meeting safety factors. It means all the factors required, I mean for bending and pitting, met the requirements. We have required value, wheel the first, the second. Required value, the first, the second wheel for bending, static, bending dynamic limited, bending dynamic unlimited, precisely like it is in here. And the same in here for pitting, precisely like it is in here. If we could have scoring, also scoring will appear. We may also look over the numbers, not on the charts. And finally, it is a result given in the files. For instance, we may inputs, checks, it means checking parameters, main grade parameters of ISO, and bending, for instance, and pitting. We have very narrow pitting, therefore let's open pitting. And we have the results of pitting. And the others as necessary. The same way, you can use all these files for further design or classification purposes. The other possibility is to calculate the gear like DNV. Yeah, some differences, but mostly it is going the same way. Also, you can may open bending, field pitting, and the others. For instance, bending, we will have some bending results, including safety factor required and safety factor actual for particular scopes. For this, we may use complex solver, which are described in here, which is giving the possibility to go from the blank project up to final results. Let's go through. We shall define the method of calculation, strategy of solving diameters or modula, define which area are, let's say, critical been taken during answer, is it okay or not? Let's assume that it is okay. Every time the geometry check is given. We have some parameters for wheel, the first or the second, with some mixture we may choose. On the base of this we have the proposal, but we have also the possibility to calculate two proposals like it is described below. If we will calculate, we will have description in here. Let's choose the first method. Then the proposal, the first data are set into the present data. Let's calculate. We have final results. As we can see, the pitting is critical much more than bending because the factors are lower for pitting, about the safety factors, and it is all for solving. Of course, every time after this, or in fact, it is included in solver and calculation, but especially after changing of data, we may use parameter check. I mean geometry and cooperation. Of course, it is okay now because we haven't done any changes on data, input data. We may optimize helix angle, and we have information what has been done. And we may optimize helix angle, not helix, x factor to minimal, to optimize minimal calculated ISO safety factor. It means it is the idea to make the lowest safety factor higher. It means equalize loads, tension, let's say, or risks. And it is the proposal been given after this elaboration, and we have the results. Coefficient x1, and we may see that coefficient x1 was changed from 0 to 0.5 and minus 0.5. And in this case, the values here are more equalized, as you can see. It's all for calculation. We may also, let's say, calculate wheel measurement values by cylinders and balls in here, or by teeth in here. Let's open. And then you will have some easy description for quality purposes. We may also perform wheel reconstruction. Data for reconstruction are placed in here. On the base of this data, geometrically, the parameters are set up as here, and you can use them for reconstruction of wheels from the workshop, for instance, or the other. It's approximately all. Thank you very much. Have a fun.